Today I am discussing about selection of rotary files based on their taper, that is constant versus variable taper. First, let's know about the meaning of these variable and constant taper. All the canals are narrow at apex and their width increases toward coronal. This gives them a taper, and in same way to prepare these canals, tapered instruments are required. But this increase in width is sometimes gradual, that is constant, but mostly irregular. So constant taper files are the files where increase in width is constant, like 2% or 4% or 6%, etc. Many rotary systems like money, high flex, wall flex, gold, etc. follow this. But in some systems like pro taper, V taper, etc., taper of file is different at different levels. One thing you need to understand here is in tapered files, width of file always increases as we go coronally, but the taper percentage can be less or high at different levels. In variable taper files, here it can be 8% or here it can be less like 4 or 5%. This means in apical part width is increasing with the rate of 8%, but in middle or coronal it is increasing at a rate of 4 or 5%. While on constant taper files this increase in width is constant like 4%. Now variable taper files prepare the canal in lengthwise manner. That means S1 will prepare coronal third mainly, as the file is manufactured in a way that the taper is less in apical and middle part while it is quite high in coronal part, which gives sudden increase in width in coronal part. In same way, S2 prepare middle third and F1 will prepare apical third. You can further enlarge apical third with F2 or F3. So this system prepared the canal in crown down method, coronal, middle and then apical third, and that is the advantage of this file. Then this system is easy to understand. You need to just remember the sequence. This system works very well in wide canals. But the main problem is there are high chances of instrument breakage in apical third especially. This is because S1 and S2 will not prepare apical third, and as soon as we put F1 for the apical third, a lot of resistance to file occurs because canal is very narrow in this part but taper is quite high, that is 7%. This induces cracks in the dental walls which can fail the treatment in long run. Then this system doesn't give you flexibility in preparation width. That means if you feel that preparation is not sufficient in coronal and middle third, you have no choice apart from hand files. If canal is narrow, then also you are bound to prepare the canal till F1 at least, which is quite large for narrow and curved canals. So this system is not so suitable for narrow and severely curved canals. As you see, the preparation size of F1 will be more than 40 number file at 3 mm from the apex. Now coming to constant taper files. With these wall flex gold files, preparation will occur both length and width wise. W1 is an orifice opener which prepares coronal half, or you can say straight part of the canal. Then W2 is a glide path file, or you can say pre-flaring file, that is 19.2%. Then W3 can increase apical preparation to 24%. That means from 19.2% to 24%. In same manner, you can increase taper by W4, that is 26%. Or if you want to increase the apical size, that will be done by W5, that is 25.4%. So you can totally control the preparation as per the requirement. You can further enlarge to 25.6% or 36% in wide canals. If you feel that canal is wide in coronal half or narrow or curved in apical half, then you can do 4% preparation in apical half and later use 6% file to prepare the coronal part. So this system gives you flexibility and freedom to prepare the canal as per the need. Then file insertion is also very smooth as you are not directly jumping to 7% as in case of F1. Here it is gradual from 2% to 4% to 6%. That's why it can be used in all type of canals. But this takes some extra time in preparation because of multiple instruments. It is always better to put little more time rather than landing in complications. So there are many factors which decides the quality of rotary file, like the metal used for manufacturing, type of cross section design, then pitch and helical angle also plays a role. But when it comes to taper, I feel that constant taper files produce better results, but it requires extra efforts too. Thank you.